Read this sentence out loud. The old man the boat. Now read it again. You almost certainly stumbled the first time. Your brain committed early. The old man is a noun phrase, and then couldn't figure out what the boat was doing. That stumble is called a garden path. Your parser got fooled. And so does every computer parser, at least on the first try. Video 4 of Lecture 7, Parsing, Finding the Sentence's Skeleton. The task that revealed how weird language is 50 years before anyone had a neural network. Today we walk the two rival approaches, the probabilistic grammar era, the neural parsers of today, and why the classic garden path examples still work on every model shipped. In video 3, we tagged every token with a part of speech. Nice tidy label per word. But labels alone don't tell you how the words relate. What's the subject of gave? What's the direct object? What noun doesn't the park modify? That's a structural question, and it's exactly what parsing answers. Third station on the belt. Today's puzzle. Chomsky proved sentences are structured recursively in 1957. The field has been trying to recover that structure automatically ever since. Why is it hard? Because the same string of words can have wildly different structures. The parser has to guess right, using probabilities, context, and increasingly, a transformer. Today's 3 beats. First, the two rival ways to draw the skeleton. Constituency trees, dependency arcs. Second, the probabilistic era, PCFG, head lexicalisation, Charniak, Collins, numbers on grammar rules. Third, neural parsers, and why they still fall into the same garden paths humans do. Beat 1. Constituency parsing. This is the classical Chomsky view. A sentence is a tree. The root is S for sentence. It branches into NP, noun phrase, and VP, verb phrase. The VP branches further. Every phrase is a group of words that acts as a single unit. If you can substitute a pronoun for it, it's a phrase. If you can move it as a chunk, it's a phrase. Now the rival view. Dependency parsing, same sentence, no phrase brackets. Instead, arcs between words. Gave is the root of the sentence, the main verb. Mary has an arc labeled in sub J pointing up to gave. John has a neob J arc. Book has a dub J arc. The has a det arc pointing to book. Every word except one gets exactly one arc. The result is a directed graph, not a tree of brackets. Which one do you use? Depends on your goal. Constituency trees carry the traditional linguistics. Great for teaching syntax. Great for languages with rich phrase structure. Dependency parses are more compact, work better for languages with free word order, Czech, Latin, Hungarian, and are easier to feed downstream to NER and semantic role labeling. Most modern NLP pipelines default to dependency. Spacey defaults to dependency. Beat 2. The probabilistic era, 1990s into the 2000s. Take a context-free grammar. Rules like S goes to NPVP. Attach a probability to each rule, learned from a tree bank of hand-annotated sentences. Now you have a PCFG, probabilistic context-free grammar. When multiple parses are possible, pick the one with the highest product of rule probabilities. Simple, elegant, dominated parsing for a decade. The insight that pushed PCFGs over 90%. Head lexicalisation, Charniak 2000, Collins 2003. The idea, the head word of each phrase matters. VP goes to VNP is a generic rule. VP headed by eat goes to VNP headed by pizza is way more informative. Attach the head word to every non-terminal and let probabilities depend on words, not just categories. Suddenly parsers understood that people eat pizza but rarely eat concepts. Beat 3. Neural parsers, Chen and Manning, 2014. A tiny neural net over the parser state, the stack of partially parsed words and the buffer of remaining words. Predict the next action. Shift, reduce, attach. That paper started a wave. By 2017, everyone was fine-tuning BERT for parsing. Modern dependency parsers hit 95% labeled attachment score on English. But garden paths still bite. The old man the boat, the horse raced past the barn fell, the complex houses married, and single soldiers. Each one starts with a highly likely parse that turns out to be wrong. A parser committing early to the frequent structure gets stuck. Modern neural parsers handle these better than PCFGs did. They're better at using long-range context, but they still fail on the trickiest cases. Attachment ambiguity is the everyday problem. I saw the man with the telescope. Two structures. Either I have the telescope, the PP attaches to saw, or the man has the telescope, the PP attaches to the man. Both are grammatically legal. Choosing depends on what the sentence is about, which is why parsing without any semantic input has a permanent ceiling. Practical picks. Production, Spacy's dependency parser. Fast, 94% LAS. If you need Constituency, Stanza, or the Berkeley neural parser. If you're teaching syntax, draw constituency trees, they're more visually intuitive. If you're debugging why an LLM misinterpreted a sentence, try running it through a real parser and see if the parse tree agrees with what the LLM thought. 3 takeaways before the quiz. 1. 2 ways to draw the skeleton. Constituency trees for phrases, dependency arcs for word-to-word relations. Modern pipelines default to dependency. 2. Probabilistic era. PCFGs, with head lexicalisation. Charniak 2000, Collins 2003. Numbers on grammar rules, decided by heads. 3. Neural parsers. Chen and Manning 2014 and onwards, hit 95% LAS. Garden paths and PP attachment still leak through. That's semantics, not syntax. Quiz 1. In a dependency parse of Mary gave John the book, what is the root of the sentence? A Mary, B gave, C John, or D book? B. Gave. In dependency grammar, the main verb is almost always the root. Every other word attaches to it directly or indirectly. Mary attaches with NCUJ, John with IOB, book with DOBJ, the with det pointing to book. Quiz 2. Why was head lexicalisation the trick that pushed PCFG parsers over 90% accuracy? A. It made trees smaller. B. Attaching the head word to each phrase let rule probabilities depend on real words. So the parser knows people eat pizza but rarely eat concepts. C. It doubled the number of tags. Or D. It was required by Chomsky. B. Charniak 2000, Collins 2003. Plain PCFG rules, like VP goes to VNP, are too generic. Lexicalized rules like VP headed by eat goes to VNP headed by pizza. Let probabilities reflect what verbs actually take, what arguments. Semantic-ish knowledge snuck in through the syntax. Quiz 3. Why is the old man the boat called a garden path sentence? A. It contains a garden. B. The most frequent parse. Reading the old man as a noun phrase turns out to be wrong. The correct parse has man as a verb. C. It has too many words. Or D. Chomsky invented it. B. You're led down the garden path by the frequent structure and then have to backtrack. The old is the subject, man is the main verb, meaning to staff. The old people are staffing the boat. Every parser gets this wrong on the first pass because man is overwhelmingly a noun. Back to the puzzle. Parsing recovers the sentence's skeleton, constituency for phrases, dependency for arcs, PCFG for probabilities, neural for state-of-the-art. Third station done. Once you have the skeleton, the next station wants to know which of these words are actually names, people, places, money. That is named entity recognition. Video 5. Next time, named entity recognition. NER. Pulling people, places, organizations, and money out of raw text. Biotagging. CoNLL 2003. And how a BERT-based NER model actually decides whether Paris means the city or the person. Hit subscribe.